Each game is a composite, made up of many components aside from its core loop. It lives and dies on whether the core game loop is engaging, but it is the secondary features, the UIs and the mechanisms running in the background, that move a project from a proof of concept into a proper experience. The toy platformer we've been actively working on is teetering on the brink between just a prototype and a very unpolished game. Therefore, a lot of the work in the foreseeable future will be on getting it over this line. Today's platter is one of those numerous secondary things, a mapping system and UI related to it, wrestled by me from the cold dead hands of a merciless god at 2 AM some weeks back. Let's talk about it. Before plunging cheeks first into the gory details, let's spend a second talking about why a mapping system is a good idea for the project. I've been saying that this is just a platformer, but at this point it is taking to a Metroidvania formula more and more, which could have been predicted from the inspirations mentioned in the past. This prototype will have a world, probably a pretty compact one, that you as a player need to explore on your own to make meaningful progress. This invites keeping track of your progress, ticking things off of your imaginary to-do list. A map of the world lessens the friction between the exploration and the satisfaction of closing those open questions, and, at least partially, eliminates the frustration of being unable to do so. This frustration is exacerbated by us working in 2D with sprite tile maps. Our world runs the risk of being visually repetitive, and while I'd like to be able to make most locations look unique and interesting, there's only so much time and effort that can be put into the project. So, having a mechanic that alleviates some of those risks is worth it in my books. Lastly, as already said, we are figuring things out as we go. I can't tell you with a guarantee that a minimap system is imperative to this project until it is in and we see the results. It seems like a good idea now, and therefore we are gonna do it. And as a postscript, it would be disingenuous of me not to say that I just want to get my hands dirty on some non-completely trivial UI. The next consideration is, what kind of a map system do we want? The natural option is to display our world room by room, not treating any uncharted lands. This is a staple of many Metroidvanias for a reason. The rooms themselves are rectangular in shape, which was a decision made by me much earlier in the project to make the geometry of the world easier to lay out. This decision is going to make our life here much simpler with a room-by-room map. As for other features, and this is a personal preference, I find being able to put your own pins on a map really endearing. It evokes the idea of being on your own little adventure in my mind, which I think is very comforting. Given all of that, let's introduce the main inspiration for the mapping system, which will surprise absolutely nobody. We won't be making a one-to-one copy of the UI, but we will be taking a lot of cues from it, as it fits all of the features we want from our implementation. Having convinced ourselves that we want a map, how do we display it? A map is two-dimensional, displaying some chunk of the world, typically much larger than what you can see in the game, so that you can orient yourself. After some considerations, I decided that I do not want it to always be on screen, like in Super Metroid. It just takes away from that whimsy of exploration. This leaves us with opening it up separately as a UI window. We need a coordinate system to physically draw the thing and to be able to modify it at runtime. Actually, there are 3 systems that we'll have to work with. First, the world coordinates, where the player and the rooms physically reside. Second, the canvas coordinates, where the UI elements live. And finally, the virtual map coordinates, where the logical pieces of our map will be. The first 2 should be fairly self-explanatory. The final one is something we will construct ourselves. Originally, I had made all of our rooms be made up of large squares, and now we can reap the side benefit of that choice by making the smallest possible room a single cell in our virtual coordinate system. The 3 spaces will be interdependent. Our map coordinates is where we will actually lay the thing out. These will be translated into the canvas coordinates to draw the UI, and we will be occasionally reaching into the world coordinates for the interactive elements, notably the marker for the player's current position. Okay, so our map is split into cells. There are 2 options how to populate it. Either the cells for each room are going to be generated on the fly, or we are going to have an external static texture drawn by hand that we split up into cells internally. The former doesn't need any maintenance once we set it up, while the latter is a bit more hand-holdy. However, option number 2 has an important advantage. Because the texture is drawn by hand, it can have an arbitrary number of details on it, including various vignettes and patterns. This is, in my opinion, a big enough deal to warrant the additional work of updating it whenever the rooms change during development. Getting started with this option will also be simple, because we have this rough map already drawn out from the initial planning done for this test area. After cleaning it up for a bit, we have the graphics for minimap ready. Putting everything together, our map currently looks like this. And what do you know, this is enough to get to work on the interactions. The first interaction to handle is also the simplest. We should be able to pan and zoom around the map. The whole fundamental point of the thing is to be a shorthand for making sense of the bits of the world that you cannot currently see in the game. As such, you as a player have to be able to focus your attention on its various sections as you see fit. The implementation is about what you would expect, nothing too interesting. We just check for players' input and translate those into the target positions for the map's graphics. To make sure we stay within the same window, we throw a rectangular mask on our canvas. There is only one noteworthy thing. When we zoom in or out, we don't scale the game object with the map graphics itself, we scale its container object, a level above in the hierarchy. This way, we avoid having the zooming happening relative to the map's current position, which looks weird. With this, it's only a matter of throwing some bounds on top of the system, and we're good. The next item on our expansive list of like 4 features is auto mapping, or dynamic map discovery. Buckle up, because this is about as complicated as this topic will get. The player shouldn't see the entirety of the map before they've had a chance to explore the world. That would kill all of the wonder of having a completely unknown area open before you. The alternative, then, is to only reveal the rooms you've already seen, and maybe some limited additional information. Perhaps to no great surprise, I am not a fan of the Ubisoft approach of scattering unexplored pins everywhere, so that information will genuinely remain quite limited. To spare us all a tiny sliver of time that we are never getting back whilst on this mortal coil, I came up with a solution which, at the time, felt very simple and elegant. Let's split the map between 2 layers, the actual graphics and the visibility mask, the latter governing what is displayed to the player. Because we want our progress in the world to be visible in real time, it should also be updated dynamically. Since we have split the map into cells, the process here is pretty simple. We just need to keep track of which rooms the player has visited and then translate that information into a displayable texture. The first step is trivial. We can have a tiny separate class keep track of a collection of IDs for the rooms which we have visited, and have it updated upon entering a new door. The second step is a bit more involved. Our underlying texture is static. The rooms do not change their place. Thus, each one unambiguously occupies a single chunk of the texture. Because our world doesn't change, this map position and size can be recorded manually alongside other room static data. We can now translate player entered room tutorial-04 into region X should be white on the mask. This ended up being a bigger piece of work than I expected, mostly because it was the first time that I dipped my toes into dynamic texture generation, and as such, some trial and error was necessary. After what felt like being stuck in an endless loop of doing a thing and then realizing I was being stupid on an entirely new, hitherto unexplored coordinate system of wrong, I got it working. You know how they say that the world isn't all black and white? Well, my world is! In fact, those are the only 2 colors we're working with. Here's how a baby mask is born. We start with a blank black texture, iterate over the cells which should be white, and fill out their relevant pixels. This is functional, but there are a few things we can immediately improve. Let's replace the texture format with alpha 8 to get rid of unnecessary RGB values, We won't be using them anyways. Let's also set the texture's pixels directly, thus avoiding all of the unnecessary garbage due to creating a new object for each pixel we work with. After the good old index struggles of squeeze a 2D array into 1D variety, we have the thing working. Please ignore the lag as it oscillates between the two test options. Actually, no, don't ignore the lag. In fact, make note of it lagging. Now, watch how we take care of that by making our algorithm slightly less stupid. First, let's draw the mask only when necessary. This speaks for itself. Second, let's stop redrawing the whole mask from scratch every single time we update it. All changes happen in a very predictable way, so let's pre-create the mask on startup and only occasionally update the relevant bits. The sprite still needs to be recreated every single time, but that is still much better than doing absolutely everything from scratch. Finally, just straight up shrink the resolution. We don't need the mask to be the same size as the final map in pixels. I found that having the texture be of optimal size, 1 pixel per cell, was causing issues with transparency, which are probably because of automatic interpolation happening on upscaling. I'm sure there is a way around it, but I haven't found it at the time of implementing this, so for now, we accept the fact and raw dog the consequences. Finally, we have a map that works. There's just one issue. I don't know where I am. Let's solve this. After this small intermission from our corporate overlords. No, I'm joking, no spoilers. But I do want to go off on a short tangent. Let's step away from the minimap and talk about Unity's versions. As already stated at some point, the very first prototype for this toy platformer was made in a delirious haze somewhere at the end of 2021. Since that fateful month, this project saw no updates of the editor version. Perhaps this is my generally risk-aversive nature speaking, but I am against grabbing the latest version of important tooling the moment they are available. Certainly not in the middle of a project. New things, all kinds of new things, not just software, are subject to the curse of the bathtub curve. Most issues happen either at the very beginning or at the very end of a thing's lifecycle. For a long-running project such as this, however, updates are generally unavoidable. Up until now, I've been writing on Unity 2020.3, and many new shinies have been added to the engine since then. The universal rendering pipeline, the new UI toolkit, and the new input manager. And also probably a whole bunch of other stuff that I do not know of. And neither of these are fresh features, they've already gone through the first round of growing pains. So it was now that I decided to hop onto a newer editor version. In the spirit of being on the safe side, though, we will stop at Unity 6.0, the latest LTS version, for the time being. LTS versions are nice, typically receiving important updates without getting the fresh out of the oven features of newer minor releases. The migration process was painless, probably due to the small size of the project and the basic layout of its guts. I was done in 3 steps. First, jumping from 2020 to 2021, then to 2022, and finally to Unity 6.0, doing a quick sanity check in between each jump. With that, the project now has access to a bunch of shiny new features, which we will make use of in the future. For now, let's jump back and wrap up the last mapping features. We left off having a functional map that's not very useful. We can't figure out where we are just by looking at it. This is the time to introduce a player position marker. The position of the player within the world is known, the room that is, and we have access to the map positions of all rooms, so what we need is to simply move a pin of the player to the map position of our current room. Simple, right? Yeah, it is actually simple. However, I work on this mostly under the veil of the night, the hours where simple arithmetics are especially puzzling. The code is straightforward. Find the current room's map position, the bottom left corner, divide its size in half to get the offset to the center of the room, then get the center's position in map coordinates, and finally translate to the canvas UI coordinates. I have, in proper developer fashion, fucked this over backwards in ways seldom considered showable to the general population. Nothing a proper night of sleep won't fix though. Now comes the point when we get to have fun. How about seeing where the player is within the current room? No longer a question of functionality, this is a quest for style. I want the current position pin to move around on the map while you're moving around inside of the room. Going back to our code, we just need to replace the static offset of the pin with a dynamic one. This requires a bit of preparation. To get one's relative position inside a room, we must first figure out how large the room is. Practically speaking, it means finding its lower left and upper right boundary points. By definition, the player will always be between those, so the relative position is then just a bit of arithmetic. And because there is no force in this world, nor in the next, that would make me maintain all of this info manually, I wrote a simple script that looks up the ground tile map of the room and grabs those points from its boundaries. Simple and completely automatic. With these preparations done, we now have our desired position. It must be scaled up correctly, since it treats whatever the current room is as a square, even though that is obviously not true. Unsquishing it is just about multiplying its x and y by the size of the room. The result will not be 100% true to the actual physical reality, but the difference is going to be so small that it's completely negligible. Finally, the dream of having an absolutely tiny little guy running around the virtual world in tandem with a slightly larger little guy running around the virtual world is complete. As is always the case, there are more things that may have been worth mentioning, but for the sake of my ever-slipping sanity, we shall move on. I have also implemented a grave marker in much the same way as the player marker, thus completing the immediately useful set of pins for the things that we have in the game. Thus, we come to the final important feature. As you explore the world, you will hit various dead ends and places you don't know how to interact with just yet. I don't want the map to explicitly tell you that you need to return somewhere, but I do want you to have the option of marking those places. As such, we can consider letting the player set their own pins on the map, as has already been pioneered by many other games, including Hollow Knight, my beloved. Let's quickly workshop this idea. When a player is looking at the map, they should be able to enter a pin editing mode in which they can set or remove their pins. The pins should be limited in number to alleviate performance worries. There also should be several kinds of them, so you can mark different categories of unknowns on the map. And jumping ahead, for the sake of convenience, whenever you put one pin on top of another, they should just replace each other. This about covers what we want to build. Let's now step through the actual implementation. Switching between regular map controls and pin settings is simple enough. We just drive it off of a bool flag and also enable this pointer. To put a pin down, we need to get from the pointer's position on the screen to our map coordinates. There is a simple but clever trick for this. Translate the pointer's position into global world space and then back into the local space of the map's container. This is possible because Unity keeps a transform matrix to get to and from world and local coordinates for all of the game objects. Add a simple offset on top of that, and suddenly we are where we want to be. As for the pins themselves, which I have lovingly drawn into these 8-pointed star shapes, let's simply pull them up to save ourselves the penalty implicit in creating and destroying them on the fly. We will set up a couple of prefabs and populate our object pool at startup, and then mark all of them as inactive. These inactive pins get hidden and put very far away, making them effectively disappear. Whenever a pin is placed, under the hood we take the next unused one, enable it, and put it on the position of our pointer. We also refresh the UI, which at this point amounts to just updating the text on this little sidebar counter. Also, as you can see if you really strain your peepers, the code is very array-pilled. I'm just in everything must be in a nice streamlined data structure and memory kind of blues. Or inspiration, illness, whatever you may call it. I was afflicted at the time of writing this. Is the final result efficient? More so than a more straightforward solution. Is it also a bit of a pain to maintain? Yeah. So if you are using this video as a reference, perhaps reconsider this bit and implement it in your own way. With this little thing done, our minimap MVP is complete. As with everything already shown, it is missing the proper coat of paint, but that is something that we will worry about later. Yo, turns out that having a side project make meaningful progress while also having a side project talking about the main side project is a surprisingly sustainable endeavor. These shorter videos are proving to be quite manageable, so we will stick with this format for the near future. In case you have not seen it yet, I now also exist on Blue Sky, where I'm posting shorter, bite-sized updates. That is also a good place to follow along with the true current state of the project. These videos, simply by nature of being made post-factum, end up always running a bit behind the real progress. On the flip side, this means that I always have a buffer of things to talk about. Do you know what we will be discussing the next time? Because I don't. There are a couple of things on the plate. The main menu and how to go about initializing all of your game components without having to tear into half of your hair, the NPC dialogue system, and just generally the interactable objects scattered around the world, and shaders, though these will probably have to be touched a bit later, as I'm still just dipping my toes into the hows and the whys with them. There have also been some more explorations into the options that I have for the graphics, as most of what you see so far are still placeholder assets. Except for this beanbag of a protagonist. I will be defending his existence in this project until my last fucking dying breath. I hope that you have once again enjoyed watching, and if the YouTube algorithm gods are merciful, I will bless your headphones with my dulcet tones and mediocre audio quality again very soon to talk about some more nerd bullshit. Take care until then.